This is Geometry 3.6c. This is the third day that we're going to talk about angle pair relations. The main thing we're discussing here is about parallel lines and what angles happen with parallel lines. This particular example, we are going to prove that alternate interior angles are congruent if the lines are parallel. But we cannot use that in our proof. We're trying to prove that angle 1 is congruent to angle 2. We know that the lines are parallel. We're not allowed to use that theorem that magically says they're congruent to each other. But we are allowed to use the postulate that is, if two lines are parallel, then corresponding angles are congruent. You're allowed to say that. We're not allowed to use the alternate interior because that's what we're trying to prove. Then we're able to use it forever forward. So, because 1 and 3 are corresponding angles, they're going to be congruent because the lines are parallel. If lines are parallel, then corresponding angles are congruent. We have vertical angles. They're always congruent. Now 3 is congruent to 1 because they're corresponding, because the lines are parallel. And 3 is congruent to 2. Therefore, 1 is congruent to 2. This is the plan that you have to set in your head. You've got to be able to explain it in your own words before you even think about filling out your proof. So we know that P is parallel to Q. That's our given information. What you're trying to what information you're given is always going to go first. What you're trying to prove is always going to go last. Always. Always, always. So you can always fill those in. So the reason for given is always the first reason that we have in our proof. Now, if the lines are parallel, and we see that from the given information, since the lines are parallel, corresponding angles are congruent. We don't want to say, if lines are parallel, then angles are congruent. That's not going to work. You've got to say the specific angle. You've got to say that they are corresponding angles. You don't use numbers. You don't name it that specifically, but you got to name the type of angle we're dealing with. Okay, so we've talked about why 1 and 3, angle 1 and angle 3 are congruent. We're trying to get all the way down to 1 and 2. That's where we're trying to get to. I've got 1 on my paper. How am I going to get angle 2 on my paper? How am I going to start? I need to talk about angle 2. What can I discuss that's going to bring angle 2 into the conversation? To get angle 2, some people say, how do I know I need to do that? It's because you need to discuss 2. You need to get 2 on the page. So 3 is congruent to angle 2. Because if the angles are vertical, we see it in the picture. That's the if part, is earlier in the picture. If two angles are vertical, then they are always congruent. We don't have to be told that. We know that. The lines are, or the angles, are congruent. So now, where does this come from? Where does angle 1 is congruent to angle 2 come from? If we know that 3 is congruent to 2, I notice that they somehow, the 2's still there, somehow the 1 took its place. How do we know that 1 is congruent to 2? If 3 is congruent to 1 and 3 is congruent to 2, then those values have to be congruent to each other. We call that the transitive property of congruence. Transitive property of congruence. You can call that POC if you wish, transitive POC, but I prefer to write it out. Questions about that? All right, we move into our next one. Here we are trying to prove alternate interior angles converse. What that means is if you have two angles that are alternate interior angles and they're congruent, then that makes the lines parallel. We are proving the lines are parallel. To do that, we need to know about specific angles being congruent. We're not allowed to use the exterior ones in our direct proof. We can't say that because alternate exterior angles are congruent. That's just using the theorem we're trying to prove. We have to use other ones, and the common one to use is the corresponding one. That's called a postulate. We're allowed to use that anywhere we need to. So, given information, let's come on over here. Let's not try to start filling it in before we discuss it. Convince yourself that the lines are parallel. Well, 2 and 7 are congruent. I'm not allowed to use that as my reason, though. 2 and 7 are congruent. I know that 2 is also congruent to 3. They're vertical. I know that 3 is congruent to 7 because 3 is congruent to 2 and 2 is congruent to 7. So 3 is congruent to 7. Both 3 and 7 are congruent with 2. Therefore, they're congruent to each other. And if corresponding angles are congruent, then the lines are parallel. That was it. We talked our way through it. Can you convince yourself of that? Use your own words. Okay, you always start out with your given information, and we use the word given. They're giving you a hint on what you need to do. They're giving you a hint that you're going to talk about vertical angles. You can either talk about 2 and 3, or you could even talk about 6 and 7. You might be asking, wait a minute, isn't 1 and 4 congruent? Aren't they vertical? Well, yes, they are, but that's not working here with 2 or 7 that we've already started to work with. You got to build from what you have. You're not even talking about 1. We don't need to talk about 1. So try to think about items that are building us towards where we're trying to go. That's how you help decide what you need to put in a proof. So I like to talk about angle 2 is congruent to angle 3. They're vertical angles. If two angles are vertical, if happens in the picture, then the angles are congruent. Right here are congruent. So this doesn't say parallel yet. So what's going to get me to be able to talk about parallel? It's best if I can get to corresponding angles, by the way. So if 2 is congruent to 7 and 2 is congruent to 3, then I know 3 is congruent to 7. That's the transitive property of congruence. POC, property of congruence. 3 is here. 7 is down here. What's our reasoning we're going to use? Only reason we can't use is talking about alternate exterior. We can't use that. But 3 and 7 aren't alternate exterior, so maybe we can do it. If corresponding angles are congruent. Okay, notice those were congruent before we talked about right now. So that's why we're talking about them being if corresponding angles are congruent. Then, what are we talking about right now? Then, lines are parallel. Then, happens right now. Up here, then, angles are congruent. That's what we're talking about. Then, lines are parallel. That's what we're talking about. You can develop your own way to write it just by realizing what you're talking about. If we would have talked about 6 and 7 being vertical, then we would have talked about 2 and 6 being corresponding. So you had some options of what you could do in there. All right, we got 2 more to go. So I would encourage you not to think about the proof so much, not to look at the boxes, but try to discuss, if you know this, why do A and B have to be parallel? Now, what I would start thinking about is what makes parallel. If you have specific angles, if you have one of these angles, then you know the lines are parallel. That's what we're trying to get to. So which one of these can we get to show the lines are parallel? Can you find corresponding angles that are congruent or alternate interior or exterior? Can you find those being congruent to show the lines are parallel? That would be the converse. And that's what we're working on here. So pause the video, give that a try. So let's discuss what we have here. We know that line X and line Y are parallel to each other. So you could put a little arrow on each one of those lines to help remind you, what do you know? You know those are parallel. That's the only ones we know are parallel. Okay? We also know that angle 1 is congruent to angle 3. So I made tick marks on them. That's to help remind me what I actually know. Because the lines are parallel, I know alternate exterior angles are congruent. So I know that 3 is congruent to 2. I already know that 3 is congruent to 1. So now I know that 2 is congruent to 1. If 2 is congruent to 1, then my lines are parallel. That's it. That is one of the 4 types of angles that we have that we need to show are either congruent or supplementary, and that will make lines parallel. Or if you have lines parallel, then those types of angles are congruent or supplementary. So now can we fill this in? You can't fill this in if you can't explain what's going up there. except you have a group of boxes that you can put a puzzle together and you might be able to fake it, but that's not going to help you in the future. So x comma y, or x is parallel to y, and we also know that angle 1 is congruent to angle 3. That's all part of the given information. We knew that 2 was congruent to 3. What do we write down? Why is 2 congruent to 3? Where does that come from? That's not the given. Well, we know that 2 is congruent to 3 because if lines are parallel, then alternate, they're on opposite sides of the transversal, so we call that alternate. Exterior, they're on the outside of the two lines that are parallel, are congruent. That's why these angles are congruent. Now it asks us to look at angles 1 and 2. That's where it's going to help us show that the lines are parallel. If 3 is congruent to 1 and 3 is congruent to 2, then 1 is congruent to 2. That's transitive POC. And what you're trying to prove is always what you put last. Always what you put last is what you're trying to prove. Now, what does that? What makes the lines parallel? We have parallel, you think this. This is what makes parallel, and this is what we have if we've got parallel. This is your answer key right there. If corresponding angles are congruent. Take a look. 1 and 2. They're the only ones that link A and B together. Then lines are parallel. Then we have what we're discussing right here. Lines are parallel. If comes earlier, then comes right now. You can put together your own if-then statements. Okay, last one. We see that angle 1 and angle 6 are supplementary. That's what we're told. We need to explain why M is parallel to N. So pause the video. We're not filling it in right away. That's not the goal. Don't read your boxes. You're trying to explain to yourself, if you know that these are supplementary, why are the lines have to be parallel? Go ahead and think about that. Come up with a plan. How are you going to make your argument that M and N have to be parallel? Remember, if they're going to be parallel, you're going to need to talk about one of these situations. Which ones of these situations can you get to? So what we notice up here is angle 1 and angle 6 are supposed to add up to 180. They are supplementary. They're adding up to 180. I know that 1 and 4 are also congruent. So that means 4 and 6 are going to add up to 180. And if 4 and 6 add up to 180, that's one of my reasons right here. If corresponding angles are supplementary, then my lines are parallel. If I can show 4 and 6 add up to 180, then I know my lines are parallel. So let's go ahead and do that. This came from the given information. Given. Supplementary means that they add up to 180. So that's going to be our next step. Usually, always after supplementary, we talk about 180. Notice the order that we need to go in. Order is very important. If comes earlier. So if two angles supplementary, then, and the then comes right now, then they add to 180, or they have a sum of 180, whichever word you like to use. If comes earlier, then comes right now, adding to 180. They're giving us the hint. Okay, that's nice. There's so much we could have talked about. They're giving us a hint to stay on track. 1 and 4 is where they want us to talk about. 1 and 4 are congruent. Well, they're vertical. If vertical angles, and I know vertical angles are always congruent. If vertical angles, then congruent angles. If two angles are vertical, then they are congruent. All right, here's the little hint. This is the one that we often forget about. This is saying if congruent, then equal. So we're going to talk about how 1 is equal to 4. The measure of angle 1 is equal to the measure of angle 4. You need the right notation. Substitution. Where are we trying to get? What's the point of bringing 4 into the conversation? What are we trying to accomplish? We could look at our boxes, but I'm trying not to do a puzzle piece here. I'm just trying to actually understand what I'm supposed to put here. The hint is substitution. I'm trying to get to supplementary. Well, for angles to be supplementary, they have to add up to 180. So if I know angle 1 and 6 add up to 180, and 1 is actually 4, then I'm going to switch the 4 and this 1. The measure of angle 4 plus the measure of angle 6 equals 180. If two angles add to 180, if they have a sum of 180, then what's happening right now? Then they are supplementary. The order matters. And the proof is showing you exactly what order to go in. If happened earlier, then's happening now. Your last statement is always what you're trying to put, what you're trying to prove. M is parallel to N. Do we know that? Do we have one of these reasons? If consecutive interior angles are supplementary, okay, that's what we have here. We finally got that 4 and 6 consecutive interior. 4 and 6 were supplementary. That's what we have. If comes earlier. Then lines are parallel. You can do this.